everybody, my name is Thomas.
My name is Andrew.
Today we're going to be working on a problem to find f of x, y and f of y, x. So what we're trying to find is essentially that those two, that's f, and f of y, x are equal. So to do so, what we're going to be doing, we're going to take the derivative of this function in terms of x. We're going to use the chain rule. The first part is going to be the inside. So the inside of this function is going to be 2x. Then we're going to take the derivative of the square root. So the derivative of the square root is going to be 1 over 2 times the square root. Okay, you catch me if I'm wrong here. Times the derivative of this whole thing. So the derivative of ln of u, say, it's 1 over u. So the derivative of ln of square root of x squared plus y squared is 1 over the square root of x squared plus y squared. So you're going to add them up, and we're going to get 2x over 2 square root of x squared plus y squared times square root of x squared plus y squared equals x squared plus y squared. Okay, the two cancel. I'm going to be left with x over x squared plus y squared. Now remember we want to get f, the partial of x times the partial of y. And to do so we're going to treat this one as a function, this partial of x as a function, and we're going to take the partial of y of this function. So we're going to end up with this. So to do so, we're gonna use the quotient rule. So it will be the top function times the derivative of the bottom minus the bottom function times the derivative on top, divided by the bottom function squared. So that's what we're gonna get. So we're gonna get x times the derivative of y, the bottom will give us, of x, sorry, going to give us 2y, parentheses, minus the function of the bottom, so it's x squared plus y squared times the partial in terms of y of x. So we're going to treat x as a constant, so it's going to be equal to 0 over the bottom square. So when we square that, we get x to the 4 plus y to the 4, and so this whole thing goes to 0. So essentially, we're going to be left with. Go ahead.
This should. I don't think you can. So that should be parentheses and 2. I don't think you can distribute together.
Oh, okay. And so we're going to get 2xy over x squared plus y squared over 2. So that's, let me write that correctly. So that's the partial of x times the partial of y. And we're going to be proving that the partial of y times the partial of x is going to truly equal the same thing.
Okay. So I'm going to do it the long way instead of doing skipping to this part. So essentially we are taking f of y. So y goes this way. gonna times this by 1/2 x squared plus y squared. That should be actually -1/2, and there should be 2x on top of here. I'm gonna put it right here. Basically, I'm doing it the long way, taking the chain, using the chain rule to multiply 1/2 over here, and 1/2 minus 1 equals -1/2 right here. I took the derivative of the inside, which is 2x, and so if I simplify that even more, I will get, these will cancel out in the end, and this will flip down, so I will get x, that should be 2y actually. Never mind, sorry. 2y, so that should be 2y over x squared plus y squared. Now we're going to do the second part, but now we're taking the partial of x with respect, the partial of y with respect to x.
The 2 should cancel.
Oh yeah, the 2 should cancel out. 2y. So now we're going
Yeah, there you go.
Okay, and now we're going to do y over x. We're going to do essentially the same quotient rule. So we're going to get x squared plus y squared 2. Now we're going to take the derivative of the bottom, and we're going to leave y on top. So when we take the derivative of the bottom, we're going to get 2x, right? And then we're going to minus that, and we're going to have x squared plus y squared, right? And y is a constant, so we're going to treat that. We're going to take the derivative of y, that would be 0. That would make that, the whole expression 0 there. In the end, we're going to get yx equals 2xy over x squared plus y squared over 2, which is the same thing.
So yeah, indeed they are equal to each other, so we just verify that and prove that they're equal. So yeah, that's what the program was asking for. Thank you.
All right, thank you.
That was good.